Alright, so now let's do a centripetal force problem. So let's say a boy ties a 58-gram tennis ball to the end of a light string that is 65 centimeters long and whirls the ball above his head in a horizontal circle. The boy exerts a force of 5.2 newtons on the string to keep the ball moving in a circle at a height of 1.7 meters above the ground. So let's say we have that information and we want to determine the speed of the ball. Now we can do this using the force centripetal equation. Force centripetal equals velocity squared times mass divided by radius, because we're given the mass 58 grams and we're given radius 65 centimeters. In addition, we're also given the centripetal force 5.2, so we can just plug all that stuff in and solve backwards for velocity. So I'll put this to the side. So, get out a pen. So, we said that 5.2 equals v squared times our mass. Since our mass is in grams, we're going to want to convert that to kilograms, which is 0.058 kilograms. So times 0.0858 kilograms, all over. Since our radius is in centimeters, we're going to want to convert that to meters. 65 centimeters, 0.65 meters. So divide it by that. Alright. And then we multiply across. 5.2 times 0.65, and then divide it by 0.058 to get v squared. And then if we plug that into our calculators, where is mine? We see 5.2 times 0.65 divided by 0.058, and then the square root of that. We end up getting that velocity equals 7.634 meters per second. Alright? So that is the speed of the ball. Now, let's see if I can pick this up. Now, let's say that we keep the velocity for, let's say that the string breaks as the ball is swinging in its circular path. We want to describe the motion of the ball at the instance that it breaks. So, if I were to draw a diagram, I can probably just get rid of that too. If I were to draw a diagram, I would have him in the string, and then it's going around in, pretend that's, okay, so the ball is going around in a circular path, right? So when we look at the circular path, we see that the acceleration goes inward, and then the velocity is always tangential to the circle, right? So when the string breaks, we would say that the ball would just keep moving in the direction of the velocity. It would just keep going in the straight line. So if it broke when the ball was going this way, it would shoot out that way. If it broke here, it would shoot out this way. Or here, it would shoot out that way. Either way, it would shoot out straight, right? And then, after the string breaks, but before it hits the ground, we would define this as a parabolic fall to the ground, because you should know that if you were to throw something off of a cliff, it would follow sort of this path. So, that's exactly what this ball is going to do, except for it's not going to be thrown, it's going to be swung out of the air, but it's going to fall down to the ground because of gravity, right? Alright, so that's B. Then let's say our next problem is, how long will it take the ball to reach the ground? Now, we can use the information provided in the original question of 1.7 meters from the ground, and using our knowledge that 9.8 is gravity, we can plug that stuff into this equation. Delta y equals VIY times change in time plus 1/2 acceleration times delta t squared. So we know delta y is 1.7, and that's the height at which the ball is being swung. Oh, I won't include units. Now, because the ball is swinging around in a circle horizontally, we would say there isn't actually any vertical velocity initial. So this would just be 0 times delta t, so this entire thing would go away, plus 1/2, acceleration is 9.8, and then delta t squared. And then we would divide 1.7, or divide 1.7 by 1/2, 9.8. So that would be 1/2, 9.8. Then take the square root of that. We would see that delta t equals 0.589 seconds. Okay? That's how long it'll take the ball to reach the ground. And then for our final question, how far will the ball travel horizontally before it hits the ground? Now this one, we're going to end up using this delta t. So our equation for D is delta x equals velocity initial in the horizontal movement times the change in time. So delta x is what we're solving for. The initial velocity, horizontal, is what we solved for in A, right? The speed of the ball. So that was about 7.634, and then we multiply it by this number, 0.589, and we end up getting, that our delta x is about 4.496 meters. Alright? So that is how you solve centripetal force problems. Ooh, it's the end screen. Click on one of these links to be directed to that playlist. And don't forget to subscribe!